Next, Flutter and AI, what a powerful combination. We have Prasanna V from Easy Infra who will be simplifying Kubernetes operations using Gen AI models. Let's welcome Prasanna to the stage.
Give a short introduction about me. My name is Prasanna. I'm working in the software industry for past 14 years. So I played various roles, right from developer, and then I worked as a tech lead, and then I worked as a DevOps engineer, and then freelance DevOps engineer, and then I started my own DevOps agency aspect. So one thing which I see in common is the impact of AI. It's tremendous. So I use AI as part of my day-to-day activities. So I use code editors, Cursor or Windsurf, and I use the terminals which are powered by AI. And mostly AI is there everywhere. So I think AI is today's technology. And one thing which I felt could be changing in the near future is the use of AI agents. So that's what mostly the talk is about. So before going into that, I work for some of the companies like ThoughtWorks, Oracle, Topta, and Easy Infra is a DevOps agency which I have. And maybe I'll give a very quick intro about Kubernetes. So I think you would have known about the talk. So it is simplifying Kubernetes operations using generative AI models. So that is the idea. Maybe I'm not going to ask who knows AI, because I think everyone here would have heard about AI. But who have worked with or know about Kubernetes? Yeah, I think Kubernetes is had disrupted the software industry sometime before, 2016-17 time, but it has not in the way AI impacted the systems. So maybe I'll give a quick intro about Kubernetes. It is not on the technical side, but rather than on the adoption of Kubernetes and things like that. So Kubernetes is a leader in container orchestration. So I think around 2013 or 14 time, Docker was launched. Docker is a technology that changed the way we deploy the applications. So before Docker, there are a lot of tools. We have to provision the EC2 instance or the virtual machines and then deploy an application there. But Docker changed the way we think about the deploying the application. They created images, containers, and then the layered architecture. And that simplified a lot of things. So I think when I was doing freelancing, out of last 7 clients, I think 5 of the clients were using Kubernetes or they are trying to move to Kubernetes. So that is the state of Kubernetes. And Docker was released around 13 or 14 time, and then the Kubernetes was released. So Docker is a container-based technology. We could able to package our application into containers, and we can run the containers. But Kubernetes helped in orchestrating those containers, which means if there are let's say hundreds or 200s of microservices running, someone should make sure the service is running fine. Someone should make sure the resources are properly allocated, and it should have the proper tooling system also. For example, it should have proper monitoring, logging, and things like that. So that's why Kubernetes became very popular. So it is very reliable, meaning if the orchestration engine itself is flaky, that caused a lot of troubles. But Kubernetes was very really reliable for the starting itself. It came from Google. The project in Google was named as BART. That was released as Kubernetes as an open source. And it has strong open source community. So if you go to GitHub, you would have seen Kubernetes has tremendous adoption. So the staff count or the people who contribute to Kubernetes, it's a huge community there. And because of that, the tool set is also very good. So and I think it's because of the tool set, the Kubernetes adoption became widely popular. And that is the first graduated project from CNCF Foundation. So CNCF stands for Cloud Native Computing Foundation. So that foundation, they want to make cloud native as a core first principle thinking. So meaning if you start building applications, you should think about cloud first, like how you should optimize the resources, or how you will optimize the cost. And those are the core set of principles. And there are like a lot of projects which are adopted in the CNCF landscape. And Kubernetes is one of the projects. Maybe I can show that. Maybe I'll show the CNCF projects at the last. So some of the projects which you have known as, if you use Kubernetes, you have known Kelly, or like Jaeger, or Istio. And all these projects are part of CNCF Foundation. Maybe some of the insights to show you, like to say like what is the adoption of Kubernetes. Like these numbers I just got from Perplexity. So like even I'm not worried about this, but the catch is like the thing to get from this deck is the adoption rate. So you see like 78% of enterprise company in USA runs a production workload in Kubernetes. That is just second to Linux. So Linux is widely used to run the production workloads, and next to that is Kubernetes. So it is like not popular, and it is growing on year basis. So even if I work with any company, they'll say like, okay, we want to migrate to Kubernetes. So that would be their first objective. And I don't know what I couldn't verify this numbers and all, but Perplexity gave this. Like more than 5.6 million developers either learning Kubernetes or they are using Kubernetes as part of their daily office work. So but the objective is Kubernetes is popular. Like, I think that's what I try to introduce Kubernetes. And but that comes a challenge. So even like this, some of the challenges which I mentioned here, those are I face those challenges in my day-to-day systems because I work for US client, which means there is a 24 at least 10 hours time difference between here and the EST time zone. So which means like someone should be there if there is an issue happening in their system. The reason for that is like maybe to understand the steep learning curve in using Kubernetes. Let's say that you want to deploy a Hello World okay? So you have to use containers to package the application. And then you have to run that container in something called a pod. I'm not going to explain what pod is, but it's a Kubernetes concept. You can think of it as a wrapper on top of containers. But that pod will be wrapped inside a replica set. That replica set will be wrapped inside a deployment. That deployment will be wrapped inside a lot of other things. It could be Istio, ROCD, whatever your company uses. The catch here is, if there is some issue or some misconfiguration in any of these things, that could lead to issues. And this is, we are talking about Hello World. Okay? So if you go to hundreds of microservices, this problem could be multi-fold. So that is the steep learning curve which I mentioned. So it's not that simple. We need dedicated people who can understand Kubernetes, who can understand the trends happening in Kubernetes, so that they can manage the Kubernetes cluster, or they can run applications inside the Kubernetes cluster. That's how it is. And the other one is the tools, practices, and patterns of usage. It varies from companies to companies. So it's not one pattern which is used in all the places. The pattern could be totally different. The technologies could be totally different. But they'll say we are running workloads in Kubernetes. So that's how it is. And this leads to one problem. It needs specialized teams to take care of the 24/7 production support. 24/7 production support is not an easy thing to do because let's say we can easily run applications in Kubernetes. But if there is some issue, some developers should be there. They should be able to go and debug the things. They should identify the root cause and fix that root cause also. That is a challenge here. And which means if night 2 o'clock something happens in India time, I have to get up at night 2 o'clock and start debugging things, which is really a pain. So what was happening before is this is what people are doing. They have dedicated 24/7 support team, which means they work in multiple time zones. So I work with people in South America, India, and there one more time zone. So they'll ensure the 8-hour shift is clear, and they'll make sure the application will not go down. Even if it goes down, someone will be there to respond. So that's one approach. The other approach is write extensive runbooks. So I'll just explain what is mean by runbooks. So runbook is a document which will detail, like for example, if this issue occurs, then these are the set of commands you have to run. And once you run these commands, you get some more information. Use that information to find what is the actual issue is. So that is called as root cause analysis. And this will be stored in a log, like say Confluence or whatever it could be. So they write a detailed runbooks, and someone will have to go and execute that runbook, find the information, analyze like what's happening inside the issue. So that's how like things run. And the last method is increase the service level objective to more than 1 hour. So which means like when the developer or the DevOps engineer comes in the morning time, they'll go and start working on the issue. Which means if the production is down for 1 hour, it should be acceptable. But it's not a case. Like, it's not a practical thing in many of the systems. But that's how it is. So it's that bad actually. But now things have changed a lot. So when they say like the adoption of AI and AI agents, I felt like there's like a lot of potential in this 24/7 support. Already like chatbot is tremendous. So like whatever the support query which we have, it can go and respond very well. So we have large system, which means the LLMs, the large language models, can understand our company data and can respond like what is our need. The same thing can happen in the infrastructure side also. So whenever there is an issue, we can have agents to do it. Like the GenAI and the agentic RAG system. So this is mostly going to be the top objective. Like runbooks as RAG or knowledge base. So even here, we have to create the runbooks, but that will be done as part of our day job. Like we'll create extensive runbooks. We'll give the commands to say like, okay, these are the commands to run. These are the places to go and query things. But that is at least a manageable effort. But once it is done, it will be converted into RAG or knowledge base, which the LLM models can use. And we can create custom toolset or agents. When we say custom toolset, for each and every step in the runbook, we can say like this is the actual command to run or this is the actual tool to use. So we can create those things. And the last one is keeping human in the loop. So for example, like when we are going to execute something in the production system or in the environment, we can always keep human in the loop. Like someone should approve, some auditing should be in place to say like, okay, this person approved this command at this point in time, and this is what audited, and this is the output of the command. So that kind of human in the loop mechanism is popularly used. The other one is like human like debugging. So for example, like when I try to go and narrow down the issue, so I'll try to look at various places to find what is the root cause. And once that is done, I'll try to narrow down to say like, okay, this particular component is the issue or this particular service is causing the trouble. That kind of debugging, like the human like debugging, that is possible with AI agents. So the different agents will have the metrics, it will send to LLM, and that will do the analysis part for us. Maybe what I thought is like, I don't have that much depth. Mostly I thought I can showcase a demo on how all these things are happening and what are the tools which you can use. So like you can also like try to simulate this kind of situation in your work environment also. Yeah, so it's a demo time. Mostly my talk is that's the only theoretical part. So mostly I'm planning to show a demo. But just to give like what are the demo pieces which I'm going to show. So there are like 3 demos which I want to show. One is like basic debugging. Like for example, I will try to put a very basic issue which we can go and see immediately. But how we can leverage the open source tools and technologies to do that. The second one is like a slightly complicated issue. It's not like a very straightforward one. And the third piece is like integrating all these things together. Because what I will show the first 2 things, it will be like a very basic one. But the third one will be like integrating different services and showing like how things will happen. Yeah. And also like if you have any questions or anything, please let me know. I don't know if it was fast. Maybe like if you want me to slow down, maybe like I can repeat the things also. So as I mentioned, like this is the first demo I want to show. the basic debugging using the tool called as Combs GPU. So this is an open source tool. Maybe like I started working with a tool called KNS GPU. So that is again part of CNCF Foundation. So this is it got adopted as part of CNCF, which is like the foundation behind Kubernetes. So this is like again like we saw that trend, right? Like a lot of GPTs are there. So maybe it's called as KNS GPU. This is one tool. The other tool is it's called Combs GPU. Again, like it's an open source project from a company called Rollerstar. So this you can see like it's a on-call assistant for Prometheus alerts. Prometheus again a technology which is used for monitoring Kubernetes cluster. So this is what I'm going to showcase. And the repository for this is going to be the entire code or things like that, or like how we can simulate various scenarios and see like what happens and how the debugging happens. Yeah, I'll go to the So that is a tool called as K9S. Maybe I think like some of you might be aware of this. It is a CLI tool for running Kubernetes workloads. So that is like KNS is Kubernetes, KNS is K9S. We use that one. And maybe like I already have this. I'll do this one. So just to make sure that it's in a plain state. So we have a plain Kubernetes cluster. Basically, I am running one Kubernetes cluster in AWS EKS. So it's a managed Kubernetes from AWS system. And what I'm going to do is, first I'm going to deploy one pod that will be having a Kubernetes. So I'll say like cable kubectl. And this is one more tool. kubectl is a tool which we can use to connect to Kubernetes cluster. So I'll say like k apply scenario 1 invalid pod. So I'm intentionally like creating a pod which is not having or like which is having some issue with it. So you can see like the pod got created in the Kubernetes cluster, but you can immediately see it's having the status as error image pool. At the time, what people should do is like maybe like, this is a very trivial error. So there is something problem with the image. So like it's not working properly. One way to fix is like you can go and see what is happening in that image or what is the image version and things like that. Or we can use Combs GPT and ask the question, what's happening in the Kubernetes cluster. So what I do is I go to the README and then so before that I want to set up my OpenAI. So I'm using OpenAI to as an LLM model. So I'm using GPT-4. So you can use that as an LLM model, and then you can use a toolset which I defined. So I can say something like this. So I'm just asking what pods are unhealthy in my cluster, which means it could able to go and say unhealthy pod is broken pod, and this is in the default namespace, and this is a error message pod. Okay. So it could able to identify the image pullback off, but this is not not the intention. So the catch here is, for example, if I say something like how to fix broken pod. So if I do this, again like the same things will happen, but you use a different tool set to identify what it should do. Like it will go and use tools from the tools.point. It will say like broken pod fails due to image pullback off. The image nginx.1.abc is not valid. But what LLM did is go and check the actual Docker registry itself. It said like okay, the actual image to use is this one and not that image. So what I do is I come here, I go to impact pod. I say like instead of this one, I'll use this as an image. This is what suggested by the LLM itself. And if I try to do the same thing again, apply the scenario, which means like I changed from invalid image to valid image, and if I try to do this, once this pullback off is done, the pod will go to running state. If you see here, like I didn't do anything. Like I just asked OpenAI, providing set of tools to go and check the things in my cluster. It could be able to give me the result. But this is a very, very simple case. Like anyone can go and solve this one. But I'll show a slightly advanced case. Maybe I'll just bring up this. I'll say showcase the scenario 2. Where it's not that trivial to see what's happening there. And then I'll just go through the code also. Maybe I'll not go deep into the Kubernetes specification, but I'll try to explain at a very high level concept of like what is happening there. So I just ran one YAML file. YAML is a file format like which Kubernetes understands. So if you want to create any resource, update or anything like that, like we should create the YAML files. So here I'm creating some kind of configuration. In this case, it's a SSL certificates. I'm just giving the certificates and I'm just creating a deployment. If you understand from the first deck which I showed you, like there are a lot of layers. So in this case, the layer is like the deployment I'm just trying to create, which means it will use some image and then it will run that service and then it will use all the certificates which we created using the config map. So basically, it's injecting that certificates into the actual service. And then it's checking the validity of the certificate. If the certificate is valid or not. So that's what it's trying to do. And this is a YAML file for it. Maybe I'll share the GitHub repository with you so you guys can go and check it later. Okay. But the certificate is invalid. So I intentionally gave a invalid certificate. So what will happen in this case is, so you can see like the pod is running fine. But that is like one metric which we have to see, which is the restart count. Which means it seems like the pod is running fine, but it is getting restarted frequently at a specific time interval. And it's not like very trivial to understand also. But what we can do is we can check with A and see like what is happening there. I'll ask HomeStreetPC like why the pod DB search authenticator is getting restarted. What this will do is it will try to understand from different metrics again. So it will say it will check the logs, it will describe the events and things like that, and say like it's restarted because the certificate is not a valid. The certificate got expired in this date, which means you have to update the certificate. That's what the solution is. So if you want to update, like I already have a solution for it also. So I'll just create a solution for it as well. So I'm just creating a new set of certificates, which is like a valid certificate. It will expire in the future date. So I'm just creating one more thing with the updated certificates, and this is fine. And this pod should be like 95. Okay. So I showed you like two cases. Okay. So these two cases shows the power of A and then toolset. But the catch here is it is not straightforward. Like someone has to understand the things. Someone should have to go and ask, like using HomeStreetPC, like ask the cluster, what is happening there? Or like what is the problem in it? It's not like 9 o'clock if the system is restarting. I'll not go and ask the cluster like what's happening in the system. Okay? So which means like that is a different kind of model, which is a push-based model. Whenever that's an event happening, it should be like pushed to our system, and that system should do all these things by itself. So that is the third demo which I want to show, which is like slightly complicated one, and it's not completed. So I created a demo to show how the future will be. It is not the current state, but if you have any questions or some things like that, please let me know. I just do this one so get updated with the new certificates. So what I'm going to show now is like we just built a data on top of all this HomeStreetPC and things like that. And this is not only for Kubernetes. You can same thing and happen with the virtual machines also. Or like what are the workloads which we use. All we need is an event. If the event comes, how we can process that, how we can use agents to go and debug the case. So to just showcase this one, we are running like different machines. I'm just trying to simulate an issue in one of the machines. Let's say like, that is a random issue which I don't know, and it's happening at night 2 o'clock. So the alert got triggered. I just try to simulate the issue, which is here. it's saying like this particular machine, it is that's a service called SaaS backend service, which we expect it to run, but it is not running. And you can see like already someone started replying for this, and this is nothing but our agents. So you can see like there is one agent which got triggered, which is a log agent. It will go and check the logs to see like what is happening in that particular service, like whether all the things are up or not, or what is happening. And it seems to be like no issues with respect to logs. It will go and check the actual system itself. It will say like what is the metrics of the system, like whether it's fully loaded or the disk space is full or what's happening in the system. And it will be able to find that the disk usage is 100%, which means like the disk is running at full capacity and it has no space to run new workloads, or it couldn't start a service at all. So that is a problem in this particular case, and it's not a trivial thing at all. Some person should be there who will go and check the things. And it will give us summary saying that service engineers is not running, the root cause is disk space is full, and we have to clear these two files so that like the disk space will be like cleared out. And if I say fix it, it will go and run the commands. So one beauty of this is all this happened within 35 seconds. So when the issue occurs, in 35 seconds it could be able to identify the root cause. It could say what is the solution for it also. That is the good part about the AI agents. Like even if you like it or not, definitely this is going to be the future. Because people can't depend on other people for doing this mundane work, which is like waiting for some issue to happen, and then like just jumping on that issue and fixing it. Which agents can do it really well. So maybe like, this is like a very short demo which they want to show, and I just thought like I can just show some insights on like how this is happening. So it's happening because whenever there is an event, like the event could be from cluster or virtual machine, it will be passed to LLM. That in turn will use different set of tools. It could use log agent, it could use monitoring agent, or like kubectl commands, whatever it could be. It will try to use those things and it collect the relevant metrics out of it. And once it has the metrics, it will use a knowledge base also, because we should know how the machine is being run, or like which machine to go and check. Which means we should know what is IP address, things like that, which is coming from our knowledge base. And once it has that one, like it will say like this is a root cause, this is a fix for the issue. And I think like the LLMs and the agent model, it's very well capable of doing all these things even more. This is a crux of the talk. Maybe like the objective is to show you the power of agents and how we can solve the problem of 24/7 infrastructure support. That is the idea. Thank you. Like, any questions or things like that, you can reach out to me. And I have the handle of word of Prasanna in all the places, LinkedIn or Twitter, or you can email me at Prasanna V. Thank you.
Small token of